So in this video, we're going to talk about the Lewis structure of uh, CO2 3 minus. So how would we draw the Lewis structure of uh, CO3 2 minus? Right? Well, the first thing I'm going to do is write out my atoms uh, to the left. So I have 1 carbon and 3 oxygens. And then I'm going to go to the periodic table. And right on the periodic table where carbon is, I know that's in the column where the atoms in that column has 4 valence electrons, whereas oxygen, 2 columns over, has 6 valence electrons. So everything in oxygen's column has 6 valence electrons. Again, if you're confused about how we get these numbers, I've made several videos that talk about how we come up with the number of valence electrons from the periodic table and how to interpret the periodic table. So I do this because I want to count the total number of electrons I have to place. So if I take 3 times 6, that would be 18 plus 4, right, which would be 22, plus I have 2 here, so this would be 24 electrons total that I have to place. Now, so remember, I did 3 times 6 because each oxygen has 6 valence electrons, so the total number of valence electrons would be 3 times 6 here, and then 1 times 4, obviously. So this will give us 22. But then remember, we have a negative -2 charge here, so that means that the compound in general has gained 2 electrons. So usually, when starting Lewis structures, your central atom is usually the atom furthest left in the molecular formula. So if I put my carbon atom here, at this point I'm just going to put 3 oxygens simply because I know there are 3 oxygens in the molecular formula. So at this point I'm going to go ahead and form my single bonds as a start place and see how many electrons I've used thus far. Now remember, oxygen is one of those atoms that must satisfy the octet rule. So we got to find some way to put together the oxygens in order for them to satisfy the octet rule. So I've used 2, 4, 6 electrons thus far. I still need to place about 18 more electrons out of the 24 that I have. So why don't I go ahead and form a double bond here and see where that takes us. If I form a double bond here, then this becomes 2, 4, 6, 8. So the carbon is satisfied in that regards. Alright, so the only thing I did was I satisfied my carbon's octet rule, which is 2, 4, 6, 8. So the carbon is satisfied. Now my oxygens are not, right? So if I look at this oxygen, I only have 2, 4 around it. So if I go ahead and put 2 pairs of lone pair on it, then this should be 2, 4, 6, 8. So this is satisfied. How about this? How about these two? I cannot form any more bond between the carbon and the oxygen simply because the carbon's octet is full. So the only other place I have to put my electrons would be around the oxygen, right? So at this point, this oxygen has 2 valence electrons. This has about 2 electrons around it. So I need about 6 more. And I need the same thing on this side, about 6 more. So in this case, this oxygen becomes 2, 4, 6, 8. This oxygen becomes 2, 4, 6, 8. So my valence electrons where my oxygen are satisfied in all 3 oxygens, and then my valence electrons around the carbon is satisfied. So let's count how many total electrons we've used thus far. So this becomes 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we know that we've used all 24 electrons. We've satisfied all the octet rule, so everything should be good. Now, whenever you have charges, you must put the official Lewis structure includes brackets, and then the official charge of the molecule, right? So this would be the Lewis structure for the CO3 2 minus ion. Now, as a quick reference, you notice that we have a charge of -2 here, a -2 here, and where does that actually come from? Is the formal charges, right? So again, the formal charge is a quick shortcut. Is the formal charge for any atom is simply the number of valence electrons the atom has, so number of valence electrons minus the total electrons around the atom of interest. So around atom of interest. Now, this is actually a shortcut. There's actually a formula, as you guys probably know, which is 1/2 bond in length. I don't quite remember it because I don't use it. But essentially what I'm saying is that if I want to look at the formal charge for this oxygen, then I simply take, since it's oxygen, it's going to have valence electrons, it's going to have a valence electron of 6, and I subtract that, right? So the only thing I'm doing is plugging in into this formula. So I subtract that from the total atom of interest. Now this word is actually very important because a lot of people will say, okay, well, what's the total number? Let's say we're looking at this oxygen, right? What would be the total number of electrons around the atom of interest? Well, a lot of people say, okay, this will be 2468. I'm sorry, 2468, and that is not incorrect. That's not what we're saying in the formula here. That would be incorrect, right? That's not what we're saying in the formula here. So 6 minus 8, 6 minus 8, and that will be a -2. So a lot of people say, okay, this is a -2 charge, and that's not what we're saying. So this is incorrect, right? What we're saying is that we take 6 electrons minus the total number of electrons around the atom of interest. Now, remember, in this single bond, we have one electron from the carbon and then one from the oxygen. So that's why we get a double bond. A single bond. So a single bond consists of 2 electrons. Now, interestingly, when we say the atom of interest, I'm only looking at the oxygen, so I do not care about the electron around the carbon. So that's why I would not count this as being 2 electrons. So instead, I say, okay, well, this is 2, 4, 6, 8, and then I have 1 electron contributing from the oxygen, which is what I care about, the atom of interest. So if I form a little line around here, you would see that this 1 electron would be the atom of interest, right? We only care about what's pertaining to the oxygen. So in this case, it would be 2, 4, 6, 7. So this is 6 minus 7, which would be a -1 charge. So the formal charge on this would be a -1, right? So the only thing I'm doing at this point is just showing how we get the formal charge. Again, we've already given the official Lewis structure. So the official Lewis structure would not include any formal charges or anything like that, right? And you could see that this oxygen is in the same position as this one, right? So the formal charge should also be -1 using the formula. So -1 times a -1 plus a -1, or not plus, but right, -1 plus a -1 gives you -2, which is the overall charge, right? This formal charge is actually 0, and how we do it, okay, well, we say we're dealing with oxygen, so it's 6 valence electrons minus, okay, the number of electrons of interest. So again, a double bond, 2 is coming from the oxygen, 2 is coming from the carbon. We only care about the oxygen's electrons, so this would be 2, 4, 6. So this is 6 minus 6, which is equal to 0. And again, this would be 0, right? So -1 plus -1 would be a -2, and that is the official structure.